Hello everyone, today we'll be solving the homework problems from the topic Exponents and Radicals. I've prepared a file for you. This is basically all the questions from this topic. This is the Panda book, the second edition. So you can take a look at the problems. So okay, let's get started. So I'll be solving each question and I'll try to explain everything as detailed as possible. So we have the first question: if a to the power of minus 1 over 2 is equal to 3, what is the value of a? In order to solve that, let's rewrite it like this, okay? If you remember, any number, let's say number a, raised to the power minus n, we could rewrite it as 1 over a to the power of n. So basically what happens is that if you raise to the negative power, we just basically switch the places of numerator and denominator. So if we had a divided by b to the power of minus n, you could rewrite it as, b over a to the power of n. This is essentially the same thing. Okay, now let's rewrite it. A to the power of minus 1 over 2 is equal to 3. So we could rewrite it as 1 over a to the power of 1 over 2 is equal to 3. And if you remember, a to the power of 1 over 2 is basically just square root of a. So we have 1 over square root of a is equal to 3. Now let's multiply square root of a to the right side. That's going to be 1 equal to 3 square root of a, and square root of a is equal to 1 over 3. And in order to get rid of square root, we just raise both sides to the power of 2. So we just square both sides. That's going to be a is equal to 1 over 9. So this is our answer. Let's look at 2. Let n be equal to 1 to the power of 2, 1 plus 1 to the power of 4 plus 1, etc. Up to this point, what is the value of n? In order to solve that, this is pretty easy because if you remember this property, if we have numbers a plus a plus a and etc., let's say we have n times, you could rewrite it as a times n. So basically we multiply a by the, like how many times we add a, we just multiply it by that number. So in this case, we have n equal to 1 to the power of 2 is basically 1, 1 to the power of 4 is basically 1, and up to 1 to the power of 50. The question is, how many times do we add 1? So in this case, we could do like this, okay? Let's say we have number 2, 4, 6, 8, and etc. up to 50. So this is pretty easy. Well, you can actually calculate that by hand, just by going 2, 4, 6, 8. You could write everything, but that would take a lot of time. I would suggest you to just divide it by 2, and you would have 1, 2, 3, 4, and up to 25. So how many numbers do we have between 1 and 25? In order to understand that, we just take this. We just subtract 25 minus 1 and then just add 1. So this is, those two will cancel, and then the 25 is left, which means that there are 25 numbers in this case. So n would be equal to 1 plus 1 plus 1, etc. 25 times. So n is equal to 25. If 4 to the power of 2n plus 3 is equal to 8 to the power of n plus 5, what is the value of n? When we solve these kinds of equations, the most easy way, so let's say we have a to the power of f of x, and let's say we have a to the power of g of x. So if two bases across two sides are equal, then we can just make the exponents equal to each other. So in this case, we can rewrite 4 as 2 to the power of 2, 2 squared, and 8 as 2 cubed. So 4 to the power of 2n plus 3 is equal to 8 to the power of n plus 5. 4 would be 2 squared to the power of 2n plus 3 is equal to 2 cubed to the power of n plus 5. That's going to be 2 to the power of 4n plus 6 is equal to 2 to the power of 3n plus 15. The bases are equal, so we can just cancel them out. So that's going to be 4n plus 6 is equal to 3n plus 15. That's going to be n is equal to 9. This is our answer. Let's move to number 4. This is the same thing, then x must be equal to. So we need to find x. Okay. In this case, we have 2 to the power of x divided by 2 to the power of y is equal to 2 cubed. This is pretty easy as well. If you remember, a to the power of m divided by a to the power of n, if the bases are equal, we can just rewrite it as a to the power of m minus n. So that's going to be 2 to the power of x minus y is equal to 2 cubed. The bases are equal, we can just cancel them out. So x minus y is equal to 3. And we need to find x, so let's send y to the right side. That's going to be x is equal to y plus 3. So A is our answer. Let's look at 5. 3 to the power of x is equal to 10. What is the value of 3 to the power of x minus 3? So, okay. So we can rewrite it as 3 to the power of x divided by 3 cubed. And we know that 3 to the power of x is just 10 divided by 27. So that is our answer. Let's look at number 6. It says x squared y cubed is equal to 10. X cubed y squared is equal to 8. What is the value of x to the power of 5, y to the power of 5? Well, we can just multiply them, right? So we have x squared y cubed is equal to 10 and x cubed y squared is equal to 8. If we multiply, so let's multiply x by x and y by y. That's going to be x to the power of 5, y to the power of 5 is equal to 80. That is our answer. This is pretty easy. Let's look at number 7. If a and b are positive even integers, which of the following is greatest? Okay, well, that's an interesting question, okay? So, a and b are both positive, so a is more than 0, and b is more than 0 as well. So let's rewrite by each of them. A is basically minus 2a to the power of b. And if we consider that b might be some number as, let's say, 0.1, or let's say it might be 3. So that's going to become minus 2a to the power of 3, and that would be minus 8a cubed. So this number, minus 8, would just make our number negative. That's why we don't take this a as an option. Why? Because we want to find the greatest number, okay? But because we have minus 8 here, the number would be negative. Let's look at b. It has minus 2a to the power of 2b. So what is special about this b option, which is our correct answer, is basically we have 2 here, these 2, okay? So the thing is, when we multiply any number by 2, let's say 1, 2, 3, 4, 5, 6, any number, if we multiply it by 2, that's going to be 2, multiplied by 2, that's going to be 4, multiply that by 2, 6, 8, 10. So just look at what kind of number are we getting. All of them are even, meaning that when we raise to the even number, we're going to get a positive number. So that's going to be minus 2a to the power of 2b. That's going to be just 2a to the power of 2b without the minus here. That means that we are going to get the greatest number. Okay. Why not D? Because it looks the same. Let's write D. We have 2a to the power of 2b. Well, the thing is, when we have these brackets, it means that the 2 is being raised to the power of 2b. But in this case, 2 is not in the brackets, meaning that only a is raised to the power of 2b. So the question is this bigger or is this bigger? Of course, this one would be bigger, but why? Because we are raising not only a to the power of 2b, but 2 as well, meaning that when the 2 will be raised and when multiplied by a to the power of 2b, it will be a bigger number. Let's look at 8. Which of the following is equivalent to x to the power of 2a divided by b? Well, this is easy as well. If you remember, if we have a to the power of m divided by n, we could rewrite it as square root of n a to the power of m. This is the rule. So in this case, that's going to be square root of b x to the power of 2a. Okay, this is exactly our answer. Let's look at number 9. So it says x squared is equal to y cubed for what value of z? X for what value of z? X to the power of 3z is equal to y to the power of 9. This is easy as well. Let's just raise it to the power of 3. So let's just cube it. That's going to be x to the power of 6 is equal to y to the power of 9. Y to the power of 9, y to the power of 9. Let's just make x to the power of 6 is equal to x to the power of 3z. The bases are the same, we can just cancel them out. So 3z is equal to 6 and z is equal to 2. Let's look at number 10. So we have 2 to the power of x plus 3 minus 2 to the power of x is equal to k times 2 to the power of x. Well, let's just rewrite this as 2 to the power of x times 2 to the power of 3. The bases are similar, and when multiplied, we add the exponents. Minus 2 to the power of x is equal to k to the power of x. So let's just take out 2x as a common factor. And 2 cubed is 8 minus 1 is equal to k times 2 to the power of x. So that's going to be 2 to the power of x times 7 is equal to k times 2 to the power of x. So k is equal to 7. That is our answer. Let's look at 11. Well, this is easy as well. So we have square root of x times square root of x is equal to x to the power of a. If you remember, when we have two square roots, let's say square root of m, square root of n, and then a, we just used to multiply square root of m and n, like this. Okay, now let's first of all remember one more thing as well. If we have, let's say, 2 square root of 4, and if we just, send 2 under the square root, if you remember, that's going to be 4 times, and the 2 will be raised to the power of 2. It will be squared. So that's going to be 4 times 4, and that is 16. Okay, in this case as well, let's just take x under the square root. So that's going to be square root of x times x squared is equal to x to the power of 4. Now we have 2 here, 2 here. So x cubed is equal to x to the power of a. And if you remember, I've already told you that a to the power of m divided by n is square root of n a to the power of m. So you can rewrite it as x to the power of 3 over 4 is equal to x to the power of a, which makes a is equal to 3 over 4. So the answer is B. Okay, let's look at 12. So in order to solve it, let's just copy it first of all. Let's just square both sides in order to get rid of the square root. So that's going to be 4 times x plus 2 is equal to 9 times 2. So 4x plus 8 is equal to 18. Let's just send 8 to the right side. That's going to be 4x is equal to 18 minus 8 is 10, and x is equal to 10 divided by 4. And if we reduce both sides, that's going to be 5 over 2. So that is exactly 2.5. The answer is A. Let's look at number 13. We have x to the power of AC times x to the power of BC is equal to x to the power of 30. X is more than 1. A plus B is equal to 5. What is the value of C? Okay, so we have this same basis. X to the power of AC plus BC is equal to x to the power of 30. So let's take common factor C. We know what is A plus B. This is 5. Now let's insert it here. So that's going to be x to the power of 5c is equal to x to the power of 30. So that's going to be 5c is equal to 30 and c is equal to 6. This is our answer. In this case, the calculator is allowed. So let's just try to solve that. So n cubed is equal to x, and n to the power of 4 is equal to 20x. If n is more than 0, meaning that it is a positive number, what is the value of x? Okay, well, look, so if 20x is equal to n to the power of 4, now let's multiply both sides of this equation by 20. Okay, that's going to be 20n cubed is equal to 20x. And if 20x is equal to n to the power of 4, then 20n cubed is equal to n to the power of 4. Now let's solve this equation. So that's going to be n to the power of 4 minus 20n cubed is equal to 0. Let's take out n cubed as a common factor, and n minus 20 is left is equal to 0. So n is equal to 0. Now let's make each of the factors equal to 0, and n is equal to 20. This is the first, this is the second answer. But because n is more than 0, we can't take the second one, so the answer is 20. Okay. We have to find the value of x, right? Okay, so now let's find it. Okay, so n cubed is equal to x. Let's just insert it here. So 20 cubed is equal to x. So x is just basically 20 times 20 times 20. That's going to be how much? This is 400 times 20. That's 8. That's 8,000. So the answer is 8,000, not 20. Let's look at 15. We have this equal to 333. This equal to 3. What is the value of x times y? Well, we can divide it. Let's take a look. Let's just divide this. Let's just divide the first one. Let me rewrite it as x to the power of 8, y to the power of 7 is equal to 333. X to the power of 7, y to the power of 6 is equal to 3. Now let's divide the first one by the second one. X to the power of 8 divided by x to the power of 7 is just x. Y to the power of 7 divided by y to the power of 6 is just y. 333 divided by 3 is just 111. So the answer is xy is equal to 111. So these are all the questions for the topic of exponents and radicals. Here are all the questions. So you can solve the questions first and then look at the answers and explanations as well.